So, derive integrated rate law for the first order reaction A gives product. Students, here only one reactant is given. Okay, that is reactant A. This reactants undergo reaction to give product. So, for this we can write the rate law. What is the rate law? Rate is equal to K, the rate constant, into concentration of A to the power 1. There is only one reactance, that's why A to the power 1 is given. Okay, so write the terms in the rate law. So what is K? K is the rate constant for the first order reaction. Now, you are going to write the expression for rate. So what is rate? Rate is nothing but decrease in the concentration of the reactant per time is called rate. So instead of rate you write decreasing the concentration of reactant, that is minus D of concentration A by dt is equal to K into concentration of A to the power 1. Okay. Now we can cross multiply so that we can get the same things in the same side. That is AA in same side கொண்டு வரதுக்காக என்ன செய்றோம், cross multiply பண்றோம். So D of A by A is equal to, constant is not bring down, only the reactant A, concentration of A is brought down, then this dt is bring here. Okay, so K into dt, this is taken as the first equation. Now you are going to integrate this equation with the time limits. Okay, between the limits of time t. The time t tends to 0 and the time. So integrate this equation with the limits of t, time t tends to 0 and the time, actual time taken for the reaction, and the concentration term is also integrated with the initial concentration of A is taken as concentration of A is equal to A0 and the final concentration is concentration of A at the later time. Okay, on integrating the rate equation with the limits of concentration A tends to A0, initial concentration, then final concentration A tends to A. So write the integration sign. The initial concentration is taken as a lower limit and the final concentration is taken as a upper limit, minus dA of D of concentration A by concentration A is equal to, the K is constant, so constant integrate panna vendam. Then you integrate the time dt with the initial time is taken as t is equal to 0 and the final time is taken as t. Okay, now change this integrated sign into ln. Okay, அப்போ இந்த சைனை எடுத்துட்டு என்ன செய்கிறோம், ln ln போடுறோம். ஸோ மைனஸ் ln டிஏயும் எடுத்துடணும். இந்த லான் போடும்போது டிஏ எடுத்துடணும், இன்டகிரேஷன் சைனை எடுத்துடுறோம், லான் போட்டு அந்த லிமிட்ஸை எழுதுகிறோம். ஓகே, ஸோ மைனஸ் லான் ஆஃப் ஏ, the lower limit is. Now change this integration sign into ln. So ln போடும்போது integration sign போட வேண்டாம், dயும் போட வேண்டாம், சரியா? So minus ln of concentration A to the power A, the lower limit is A0 and the upper limit is A, that is equal to constant K into T. The lower limit of time is 0 and the upper limit is T. Okay. Now expand this expression, that is first you write the upper limit. Why? Because the upper limit has a maximum value. So minus ln of concentration A minus, then minus, already one minus is there, so minus ln of concentration of A0 is equal to K. So the upper limit of time is T minus the lower limit of time is 0. So K of T minus 0. Now, you multiply the signs. So minus ln of A minus into minus of ln A0. So minus into minus plus of ln A0 is equal to K T minus 0. So that's why KT. Okay. So write this expression. Write the above expression in the division form. Okay. So first write the positive sign in the numerator. So ln of A0 and the negative sign terms in the denominator. So ln of concentration of A0 by concentration of A is equal to Kt. This expression is taken as the second expression. So to convert this ln to log, what you should do? Multiply by 2.303. So change this ln to log. Okay. So 2.303 into log. Write the remaining expression as it is. Concentration of A0 by concentration of A, that is equal to Kt. Now, we need to find out the rate constant for the first order kinetics. Okay. So, write this K alone, then cross multiply this T. So, K is equal to 2.303 by T into log A0 by A. This is taken as the third equation. Okay. Now, so what is the rate constant for the first order reaction? That is K is equal to 2.303 by T into log A0 by A is the rate constant for the first order reaction.